Now let's take a look at the filter section in Thor. Filters modify the sound of the oscillators to make them even more interesting. You can see in Thor we have spots for 3 different filters: filter 1, filter 2, and filter 3, the stereo filter in the global section. Each of those filters can be one of 4 different types, and we're going to take a look at the low pass ladder filter. But before we do, let's take a detour over to Pro Tools and visually see what exactly these filters are doing. I've loaded up a filter plugin, which is similar to what we see in Thor. I've got a low pass and high pass filter called Filter Bank F2 from McDSP, and it operates much the same way. We'll take a listen to some sound here. We have the same kind of controls: frequency, usually called cutoff frequency on a filter, and peak, usually called resonance on a filter. We'll go ahead and adjust the cutoff frequency while listening. You can hear as I turn that frequency down, I'm cutting off the high frequencies. Low frequencies are passed, that's why it's called a low pass filter, but the high frequencies are cut off. The slope of this cutoff is determined by these settings here in the dB per octave section. Right now it's set to 24 dB per octave, so every octave you go up, or doubling of the frequency, the volume of that audio will be 24 dB down, a lot. That sort of sound is associated with a Moog or Prophet 5 type of synth, also called a 4-pole filter when it's 24 dB per octave. We could move up the ladder here. You can hear at 6 dB per octave, there's quite a bit of high end left. While at 24, it's just gone. 12 dB per octave filters, or 2-pole filters, were seen on some of the Oberheim synths and Roland synths. Get a little bit different sound out of those. The other control here, resonance, we'll go ahead and play with that one. And what that does is add a spike or a peak in the frequency response right at the cutoff frequency. And that gives you your sci-fi sweep sound. Also in Thor, you'll find filters that are not low-pass filters, but high-pass filters. They're just the inverse of what the low-pass filter did. You can hear it rolls off the lows. And the resonance applies the same way. It's a cool sounding filter. Another type of filter that you'll find in Thor is the notch filter. And what the notch filter does is it just takes a bite out of the mid-range somewhere. The highs and the lows pass through, but the mids are notched. Or you'll find a band pass filter, and that's really a high pass and a low pass together. So we're cutting off the highs, we're cutting off the lows, only passing the middle band. So it's called a band pass. Good for your boxy and AM radio type of sounds. Another type of filter you'll see is the comb filter. And this is kind of a cruddy comb filter, but you get the idea. It's kind of interference cancellation type of filter. So you've got repeating bands of cuts and boosts and cuts and boosts and cuts and boosts. Yet another type of sound. This is a poor approximation, but here we go. So you get the idea, kind of a phasey sort of thing. Hopefully that will help understand what Thor is doing. Using your ears is the best though, so let's flip back. Now let's take a listen to Thor's filters. We'll hear the oscillator first without a filter. And then we'll go ahead and load the low pass ladder filter. It sounds pretty much the same until I turn the cutoff frequency knob. And to me that sounds better than the one in Pro Tools, which is good. We have the same kind of controls. That was the 6 dB per octave. We can move up the scale here. We have 2 different 24 dB per octave types. We'll turn up the resonance. That's basically what the filters do right there. We'll take a detour here into a couple of these extra controls. One is called self-oscillate. Some filters, if you turn the resonance up enough, they will actually become an oscillator. Their resonance is so steep that they cause themselves to create a tone, and you could even turn off the oscillators and hear them. So we'll turn off self-oscillate. So we're still hearing our oscillators with a strong resonance sound. But if we turn on self-oscillate, I could turn off these oscillators here. And I'm just hearing the filter resonance. If I turn it down from full, it won't go into oscillation. If you turn it up enough, it will. And a lot of synths had that feature, and you could create crazy sounds or really clashing sounds with that. The self-oscillate also does another thing, and it turns on a distortion circuit or a shaper circuit like this circuit here. Some of the old synths, if you got a loud enough sound out of the filter, it would clip. You'd have distortion inside the synth somewhere, and that would definitely shape the sound. So propeller heads folks have given us the capability of doing that. The difference between the two 24 dB types of filters is where this distortion occurs. So with a type 1, the distortion occurs at the output of the circuit on its way out here to the outside world. And type 2, it occurs in a feedback from when you turn up the resonance control. It's kind of a feedback control inside the filter. So it's really only on the resonance ringing part of the sound. And it doesn't sound as distorted. If you turn up the drive, which is really just volume of the oscillators hitting the filter, you can clip it more, kind of like turning up a guitar amp drive. We'll turn down the output volume here. You can hear that's more distorted, or really distorted here. I kind of wish that wasn't so digital sounding, but hey, there it is. It adds a lot of character to sounds, and you can turn it on and off when you're doing sound design and see what you like. There are a few other controls down here that are pretty much in each of the filter types. So we'll discuss them in this filter, and then we won't discuss them in the others unless they change. The first of them is the envelope control, the envelope amount adjustment here. If you're not familiar with envelopes, the envelopes generate something that changes every time you press a key. When we press a key, we have an attack time, a decay time, a sustain time, and a release time. See, this is the filter envelope control here. Now when I hit my sound, every key is the same, and the filter frequency knob stays the same, doesn't change. But if I add some envelope here, then I'm going to hear it change every time I hit the key. So you can hear how it flies down from some high level. It can fly up to the high level if I slow down my attack time a bit. So that's what you're hearing. The attack time is a slope up to a peak, and then peak of this knob movement here. And then the knob movement will fall back to 0 as you let off the key, and the falling back to 0 part is determined by these two. The decay is the time from the peak down to a sustained level while you're holding the key. So let's hear that. There's a short decay, a long decay, and if we don't want to decay all the way back to 0, we could decay back to halfway open. And if it's still open a bit, then we can have even more decay back to 0 after we let go. So if we're sustaining at some level here, like minus 6.8, we still get to decay back to 0 at the rate determined by the release. And we're going to need a little bit of release from this here. You can hear when I let go of the key, the filter's not closing very quickly, and there it's closing really quickly. So that's what attack, decay, sustain, and release do. They're sending this voltage that changes every time you hit the key to this cutoff frequency knob and turning it for you, the amount of which is determined by this envelope knob. Similarly, you have a velocity knob, and that affects the cutoff frequency depending on how hard you hit the key. So if I turn this knob up, and you can see the arrow points toward the envelope, so the envelope has to be used as well in order for the velocity to do anything. But if I really wail on the key, every time I hit it harder, the accent opens the filter a little bit more, which is a cool effect. The next knob is the keyboard tracking knob, and what that does is Some sounds get brighter naturally as you move up the keyboard. You know, some tuba or whatever is kind of a dark sound down low, and it can be real brassy when you go up high, or trumpet. You can emulate that effect by having the cutoff frequency increase a bit as you climb up the keyboard from low notes to high notes. That's what keyboard tracking does. When you turn this all the way up, you can hear that the filter's pretty open and pretty dark down low. If I turn it off, now when I go up high, it's not open anymore. It's just keyboard tracking. That's what it does. And then the final thing, we have a button here that says invert, and that inverts the effect of the filter. So instead of going high and coming down, it goes down and comes up. Let's see if I can demonstrate this well. I'm going to put a slow attack time. So without invert, with invert. Actually, we've got to start more open here. There it is. It's going down and coming back. So it's just the inverse of the filter envelope there. This low-pass ladder filter is called a ladder filter because it's modeled after the circuit in a Moog synth. A lot of the Moog synths, like the Mini Moog and Micro Moog, used this ladder type of circuit that they patented, and none of the other synths had quite that sound. It has kind of a neat mid-range bite, sounds real good on bass and some kinds of brassy sounds. So you get to use that type of filter. Patents have run out, and this is the digital version anyway, but you get to use that type of filter in Thor to get those sort of sounds.